looks like Teams has changed some of its picture-in-picture settings. This is kind of cool. All right, so everyone can see me, and I'm in front of my screen. This is cool. This is interesting. All right, ready to go? Let's do this thing. If this gets obnoxious, let me know, and I'll change the view. Hi, everybody. Welcome to caparea.net. I wish we were in person. I prefer doing these sorts of talks in person just because I miss people, but we can't be in person, so we'll do this virtually. This is Real-Time Revolution. We're going to talk about one of my favorite subjects, SignalR. And before we jump into a full discussion of what SignalR is, I want to talk about one of my clients. And I'm not going to name them, and you cannot guess who they are based off of this amazing graphic of the application that I made. But you probably have worked on or visited an application that looks sort of like this. And this client came to me and said, Kevin, we have an issue, a performance issue, and we heard you're the guy when it comes to real-time communication and .NET applications, and we were hoping that you could help us. And this is the issue that we have. We have our app, and there's a couple notification icons up in the top right-hand corner, and they show me on a screen grab. And it's basically, all right, there's alerts that the user needs to know about as soon as they occur. And then there's also a built-in messaging system that tells the person, hey, there's incoming emails, there's incoming direct messages, all that good stuff. And these basically show little badges with the number of things that are currently not really unread, but not acknowledged yet. So the way that it works is you have the web app and you have the server that is running on. It's .NET Core something, and the app basically goes to the server and it says, hey, how many messages do I currently have that are unread? It's not the real URL, it's a fake URL that I made up. And it sends back the response saying, okay, well, we have 5 messages. And it's the same thing for notifications. Or our alerts. How many of those do we currently have? The server just looks at who's asking, it does a calculation, and it sends back the response. The problem is that it does this every 5 seconds. There's a little timer in the JavaScript and says, okay, well, every 5 seconds, we're going to go get the number of alerts, and we're also going to go get the number of unread messages. And that sounds good in theory, and that's probably how you and I would write it going through the first draft. There's a small problem with that approach. You have the one server, maybe you're in a load balance cluster, so you might have 2 or 3, 4 or 10. Maybe you just discovered what Kubernetes is, and now you have 50, 100. I digress. No matter how many servers you have, your app connects to the one or multiple servers, and so does the person down the hall, down the street, around the world, up in space. They're all connecting to your web server, and they're all doing the exact same thing. Every 5 seconds, they're making this request. Actually, they're making 2 requests to your server to get unread count and to get the number of alerts. And that's a lot, because maybe your users are nicer than my users, but my users have multiple tabs open. So it's not only doing this per multiple tab, but it's doing that per multiple tab for every user that's currently accessing your system. And they went into the telemetry for their app, and they said, Kevin, this is the problem that we have, is that these 2 particular endpoints make up the majority of our traffic. And it's not that one individual call is expensive, but the aggregate of all the different calls happening over the period of time, they take up a lot of resources. And they try to implement some strategies with caching, and actually in the browser, they try to make it so only one tab at a time would go make the call, and it would talk amongst the other tabs. So they tried to put in all this stuff, but it wasn't really working as well as they had wanted it to. So they said, Kevin, is there a better way to accomplish this? So Those of you who don't know me, my name is Kevin Griffin. I'm a multi-year Microsoft MVP. My focus is and has been in ASP.NET, now mostly ASP.NET Core, deploying solutions to Microsoft Azure and just everything general web development. If you would like to talk to me afterwards, please feel free to reach out on Twitter. Every now and then I stream on Twitch, but you can also hit me up at my site, consultwithgriff.com. But most importantly, we weren't going to talk about this. I have a course on SignalR. It's called SignalR Mastery. It is a soup to nuts overview of everything you need to know about SignalR, going from the very basics that we're going to kind of touch on in this session, and then go a little bit deeper into some more real life scenarios and actual issues that I've run into in my consulting. You can get on Udemy. It's not $12.99 at the moment. It's actually $14.99, but it's still stupid cheap for the amount of information that I'm providing. So I highly recommend that after this session or during the session, I don't care, turn me off, go buy the course, whatever you want, signalrmastery.com.
Kevin, slide over to the right a little. I can't see the URL.
Oh my gosh, hold on.
There it is. Yes, thank you. Now I know.
Thank you, Scott. No one would have bought my course because they couldn't Google. Oh, all right. Let's go ahead and revisit our sample. So we have the web app that's out there and running. We have the server. What's the ideal way to get not just the alerts, but also the unread messages? Well, you have probably heard of this little thing called a Websocket. And a WebSocket, in the most basic terms, is just an end-to-end connection between your client app and your server. So we use this. We establish it early. We just leave it open indefinitely. And whenever something happens in our environment, so let's say a new email comes in. Well, we know that email comes in because something's probably putting data in the database. It's probably doing some sort of processing. We know that that event has occurred. So we can capture that event and we can send messages. Basically, we can push events down to all the individual clients that need to know about something that's occurred. Well, in this client's particular instance, we could take all the multiple clients and a new message comes in. Not all of them need to know about it. So we could selectively push that message to only the different folks that need to know about it. So how do you do this? You would figure, well, I could just set up my own WebSocket. I can manage that on my own. But there are cases where WebSockets aren't usable. We would love to use a WebSocket, but can't. So then I have to build some sort of backend logic that handles the case when I don't have WebSockets. But I really don't want to do that. Kevin, is there a better way? And the answer is yes. And this is what introduces us to SignalR, because the ASP.NET team, specifically Mr. David Fowler, who is probably the smartest person over there in Microsoft right now. Don't tell anyone else I said that. He and Damien Edwards came up with the basic solution for SignalR on the same criteria that I just explained. WebSockets are amazing, but they're not universally usable all the time. And there are other fallbacks that we could use, but we don't want to have to manage all these different fallbacks depending on the server and client configurations. So what if we could write one contract, one set of code that would handle all these different use cases, and I just don't have to worry about it as the developer. So that's what SignalR is. It's been around since about 2013. And yeah, let's talk. Let's just show some code, because I love doing some different demos in here. I am going to bring up Visual Studio Code. All this is available in my GitHub repo for SignalR Mastery, which is open. You don't have to pay for the course to get the GitHub repo. I am going to, though, I'm going to adjust my share. I don't want to be big screen anymore. All right. Give me one moment. Ooh, I could do side by side. What does this look like? How's that look? Oh. All right. Team's just adding new stuff all the time. All right. Let's run this application. What's wrong?
Yeah, this works better for me.
Okay. All right. So I'm just going to go and .NET Run. This should build. I don't see any reason why it shouldn't. We're going to go open it up in a browser, and it doesn't do anything at all. But I want to talk about what it should do. We are going to write a very simple application that notifies instances of this web page about state changes. And fundamentally, that's all SignalR is a platform for notifying clients, web clients, mobile clients. You can have IoT clients. The sky's the limit. Notifying these clients about state changes in the master app. So your web server, your master database, something changes in it. You want to notify all the client apps that something's changed without them having to go pull for new updates. For us, that's basically going to be, well, if I have a text box and I type in the text box, if I were to have a second version of this page, how do I sync these two text boxes together? Likewise, the checkbox. What if I want to sync that state amongst multiple web browsers? And then we'll talk about real-time notifications. That's the last demo. So this app doesn't do anything at all. We have to go write a little bit of code. So I'm going to go ahead and bring up Visual Studio Code. We'll take you on a little tour. First things first, we have the web page for our app. We are not doing anything spectacular here. This is really basic HTML. You can see I have a text box, I have the checkbox, I have some buttons. I am manually including the SignalR distributable. So I still did a npm install for the SignalR package. If you were following my SignalR mastery course, we use Webpack to show all the ins and outs. We use TypeScript for all the coding. That's kind of the way it was meant to be. But if you're not a TypeScript person, that's okay. You can still do everything in plain Jane JavaScript. If you're not using Webpack, you can still include the JavaScript directly. Those of you out there still doing jQuery, I mean, God bless you. Those were some good times. You could still use jQuery with SignalR. So we do have our own file. There's a whole bunch of stuff in here. Ooh. There's a whole bunch of stuff that shouldn't be in here. All right. All right. Well, we're just going to leave it in because I've already jumped the gun. No, we're not going to do that. We're going to clean up after ourselves. I would have sworn I had checked this demo before I jumped on. Poor Kevin, poor Kevin, poor Kevin. I know. You're all, don't look at the screen, swear. This never happens to me. All right. I set up these folders start and end, so this should be clean, but I think I accidentally mucked up my repository. Oh my gosh, I screwed it all up. I blame Scott. It's Scott's fault. Can we do that? Scott's fault?
No. Yes.
Yes, Scott's fault? Okay, I agree.
Typically.
All right. So, it's all Scott's fault.
Nothing to see here, Kevin. Just keep deleting. This is amazing. We're watching you code backwards.
Yeah. So the best part about having done this demo so many times is I know exactly what to remove.
So if you weren't, for those of you watching this for the first time on YouTube, this is called technical debt cleanup.
Yeah. Yeah. You just remove all the code and then you don't have any.
And there's nothing to look. See that app that does nothing. It's great.
Yeah.
Just ignore that using. Don't even need it. Jump around here. They got a whole class, Kevin.
Yeah. All right. So, and the kicker is it should still compile.
And
still compiles.
Wow,
yeah,
amazing. Good job.
All right. So y'all can tune back in now. All right. So we have this index.js. which is just the basic JavaScript for our application. And all we're starting with is a text box, a checkbox element, and the buttons and some reference to those. I've set up some click handlers for the buttons so I don't have to do that crap later. And then I'm also using Toastify for some fancy graphics a little bit later. So everything else, there's nothing SignalR in this app, as there should be. Over on the code side, let's start in our startup CS file, which you should start in. If you're using the new .NET 6, basically minimal API, where there's no such thing as classes anymore, you can do all the same stuff. I originally built this on top of .NET 5, and I recently upgraded to .NET 6, so it still works, but I am using the startup classes. So if you're confused by the startup class, just Google something, and there'll probably be a reference to it. If you're following this pattern, though, you still need to set up your dependency injection for SignalR. You don't have to do any NuGet installations if you're doing ASP.NET Core. It's already included in the main parent package, but we do want to set up the injections for SignalR, so all that good stuff will happen. And then we have to tell ASP.NET Core where our SignalR connection is going to occur. In SignalR, there's this concept called a hub, and hubs are pretty straightforward. They're like controllers. So if you're familiar with the MVC pattern, if you've done any of that over the past 10 years, you know, model view controllers, you have a controller that is the sole point of focus for different types of entities. So home controllers, where you put all your basic home classes, account controllers, where all your account management stuff goes, and so on and so on. In SignalR, we use the term hub to kind of represent the same thing. Think of a hub as a central connection point for all the incoming connections to our application. So it's a hub. All the connections are connecting to a central hub, and SignalR will manage that hub for you. So hubs are pretty easy to implement. They're just classes, and we'll call ours a sync hub, that implements the type hub. And I also have GitHub Copilot turned on, and it's going to try to write some of this code for me. We're going to ignore it for the most part. Let's see, this one's a using statement. So we're using Microsoft ASP.NET Signal. There we go. And I knew that off the top of my head. Yeah. A hub doesn't necessarily need any methods. It just has to exist in order to accept incoming connections. We do have to tell ASP.NET Core what endpoint we want to use, because ASP.NET Core is built on this new flexible routing endpoint model. We need to tell ASP.NET Core that when we see a request come in for, we'll call it, what do I want to call it? Hubs to sync. This can be anything that you want it to be. So if you have your own pattern for URLs, you can use whatever URL that you want to. But we're essentially telling ASP.NET Core that when I see a request come in for hub/sync, ASP.NET Core should map my sync hub to all those incoming connections. Let's pivot back over to JavaScript land for a moment, and let's set up the client connection. So assuming the server works fine, if we want to connect to the server, we'll create a new connection. So we use SignalR. Connection builder, because everything needs to be a builder nowadays. We're going to tell the hub connection builder that we want to use the URL hub/sync. This matches what was in my startup.cs, and I just want to build the new connection. There's a lot of different options you can add in here too. Maybe you want to configure logging. I don't know why my IntelliSense isn't working. But there's configure logging. You can use different prototypes or protocols for communication. There's a lot of stuff you can do inside of a hub connection builder, but we're not going to do that here. But there's a great course, SignalRmastery.com, where you can learn about all that crap. Each new connection. And we're not going to do anything else yet, except go down here to the bottom, and we're going to start that new connection. We'll go back to our, we'll go back out to the terminal. Come on, shut down. Shut down. There we go. We're going to rerun our app. Actually, I'm going to .NET watch run, make sure this works. All right, so that's running just fine. I'm going to open up my dev tools for a moment. Refresh here, ignore the 404 for the fave icon. But let's look at what's happening underneath the scenes. SignalR is creating that hub connection builder, and it's normalizing the URL to my local domain. So localhost port 5001 /hubs/sync, and then it's doing a negotiation. If we actually look at the network tab, and if I go all, we can see down here that there's a call to negotiate, which is the full path, my hub/sync negotiate. And this is SignalR on the client and SignalR on the server having a conversation about the best way for them to do business. So they're negotiating. Basically, it comes back to say, hey, we should try to use WebSockets, and we should use text, JSON to do all that work. And by the way, your connection ID for everything moving forward is, whatever they're given here. SignalR client turns around and establishes a new WebSocket connection, basically saying, okay, well, I was given an ID. I'm going to establish the WebSocket using that ID, and it gets accepted. This connection is just sitting here open. You can see if I move things around, it's pending. That's an open connection. It hasn't closed yet. If we look at the payload, the message is coming through. If we look at the messages coming through, it's just sending heartbeats. So the connection's alive. Let's just make sure the connection's alive. So we haven't sent any data yet, but we have an open WebSocket connection. Everything is good to go. Let's talk protocols for a moment. I've shown you the basic WebSocket connection, and just the theory behind it is you have one or more clients that want to connect to your server, and they do this using an end-to-end connection, meaning the clients can send messages up the WebSockets to the server, and the server can use the WebSockets to send messages down to the clients. This is pretty much the holy grail for communication, because we've created one connection to rule them all, and the client can use this as much as they want to, and the server can use that as much as they want to. But sometimes WebSockets are not available. In a case if you're behind a proxy or a VPN, it might not allow WebSocket traffic. So if that happens, what's a good way for us to fall back that still satisfies all of our needs as the developer? Well, a really good fallback is server-send events, and this has been around since the Netscape days, if I'm dating anyone out there in the audience. It works kind of like this. You have the client, and makes a one-way to request to the server, and the server establishes what it calls an event source. And event source is one way, so it's from the server down to the client. This remains open, and the server can use this as much as it wants to send events, messages, down to the client. But anytime the client needs to send a message back up to the server, it has to do that using a basic asynchronous request. So it's going to make a fetch request, push put, whatever. It's got to make a separate request for all those. It cannot use the existing event source. Well, what if that's not available for any given reason? Most times, you're going to fall back to server-send events unless you're supporting IE6. All right, if you're out there supporting IE6, raise your hand. It's all right. Hopefully you're not. But what's the worst case scenario? Worst case scenario is long polling. And you probably have heard of long polling before. It's really straightforward. It works on browsers as old as IE6, technically as old as IE 5.5. But it's basically this concept of the client opens an AJAX request to the server and leaves it open, I'm going to say, quote, indefinitely. When the server has some data to send back to the client, it uses that open connection to send back the response. The client then immediately turns around and opens a new request so the cycle can happen all over again and get back another response. Now I said quote indefinitely, so what if this is an open request? When will it get shut down? Most browsers have a built-in timeout of about 2 minutes. That might have changed with new versions of Chrome or Edge, but I think it's still 2 minutes max per request, where the client will shut down the connection and SignalR in this case will automatically turn around and open a new connection to ensure that a pipe is always available for the server to send a message back down on. So no matter what connection SignalR decides to use, you are covered because you're going to write code one way, and that way is going to be the way that all these different protocols work to send your message. You don't need to care if it's using WebSockets or long polling. Your users might see a slight degradation issue if they're using long polling instead of WebSockets, but that's not necessarily your concern. You could tell SignalR don't use WebSockets at all if that's what you want. I prefer to just leave all the options open because I'd much rather have my application usable in all cases than to prohibit the real-time updates. So quick resync here. WebSockets are the holy grail. They're always, it's an always available connection between the client and the server. They can both use that same connection. There is a con around WebSockets, and that's around socket pools. And if we have time for this, I'll talk about it a little bit, but you can exhaust the socket pool on a server by having too many open WebSockets. I've accidentally more than once DDoSed myself and killed my server because I had too many WebSockets connected between the clients and the server. That's a story for the end. Server send events is a really good fallback if WebSockets are not available. It accomplishes the same thing. The biggest problem is that the client cannot use an event source to send messages up to the server. It has to use good old-fashioned AJAX. But the server still has the capability to push data down to the client. And then finally, long polling works in every browser. If we go back, 25 years? Yeah, that's a pretty good track record. The biggest con is that it's constant connection disconnection cycles. So you are going to see some performance degradation from that. Now let's actually send some messages. In my code sample, we set everything up, but we're not actually doing any work yet. So let's set up some work to get done. We're going to go up to the top of the page. And now we had mentioned I have these text boxes and check boxes. Well, when I type something into the text box, what I want to do is I want to take the contents of that text box, send it to the server. The server will take the content and then send it out to everyone else who's currently looking at that page. Well, let's begin with the server side stuff, and let's build a client message. So we're not going to call it send message. Ignore Copilot. But we're going to say public async task. Everything in SignalR is async. So task everything everywhere. Don't use async void. That's bad. Yeah. We're going to say sync text box. And it's going to take a single parameter of the text that would be in the text box. And we want to turn around and we want to say clients dot, not all. We want to say clients dot other. And we want to tell them that we want to send a message to all the other clients that are connected that they should sync their text box and give it some content to sync with. All right, this thing wants system, so come on. What is tasking? What namespace is tasking? Scott.
Messaging.
No, it's not.
I just made that up. I have no idea. I haven't written code in 7 years.
Does anyone even know? I would just always hit auto add using.
And yeah, VS Code's not giving me IntelliSense. Oh,
System.threading?
Yeah, system.threading.tasks, I think.
All right, you get a cookie. Thank you. All right. So, all right, I think we're good so far. I don't think we need any more namespaces in this demo. All right, so let's recap. A new message is going to come into our server. We're going to tell SignalR to go to our collection of clients. Now, we get this connection of clients because we're implementing Hub. Because all the connections come into the same hub, we have basically this, I was just going to say a database that we can go to and tell SignalR, well, for anyone that's currently connected to the website, that's not me, so others other than me, I want to send a message to them called sync text box and send some different parameters. And goes back to the client. So on the client, because we have the connection, we can set up an event handler called sync text box. And this will just take a lambda or a function or a callback, whatever you want. And we're going to set the text box value equal to text. And I'm typing too quickly. Okay. That takes care of the server sending the data back to the client. So how do we send the data in the first place? Well, that's done with a local event handler. So we'll say text box, add event listener. We'll say change. We'll pass the event into another lambda. Let's go get the value of the text box, which is the target. Then on our connection, we are going to invoke, we could also send a message to the server telling it, call your method sync text box and let's pass in some data. So this invoke calls the sync text box method on the server, which then goes and says for every other connection to the server, call their local method sync text box. I'm using the same names to kind of show you that this goes two ways. When the messages go down to all the other connections, they call the local events handlers for all the clients, sync text box, and they set the text box value. All right. This should have automatically hot reloaded itself. I'm going to try this. Let's put everything side by side. Type in. Oh, promise failed. Promise failed. Method. Did I do something wrong? Yep, I did something wrong. What did I do wrong? Let me double check myself. Sync text box. Okay. Sync text box. Sync text box. Sync text box. Only thing I can think of is this did not hot reload the way I expected it to. All right, let's pull this side by side. Do a full refresh. Let's see, Kevin. There we go. I want to zoom in a little for you. There we go. So Kevin Griffin. It's syncing back and forth because as I type into the one box, hit enter, that change event fires. It takes the content of the box, sends a message up to the server. The server says, okay, we'll send this to everyone else. All the other local event handlers catch it, take the value, and populate text boxes. If I did this one One more time. So let's go ahead and open up another tab. This one's empty because I'm not maintaining state. We'll type in Scott. Now all three of them say Scott because we're syncing that state across all three of them. Now I have this checkbox here. We could technically very quickly do the exact same thing for the checkbox. It's the same procedure. So we'll say async task, sync checkbox. This time, instead of taking a string, it's going to take a Boolean is checked. And we'll turn around and say clients.others, send async, sync checkbox, and pass that Boolean, true or false. We'll go back to our client, sync checkbox. And we'll just say checkbox. And checkbox.checked is CB. Okay. And we'll add the event listener. And for text box, what is it? It's change as well. Same thing as before. I'm hoping GitHub would come in here and say, oh, Kevin, I got your back. Action.invoke, sync, checkbox, pass in target.value. Oh, I'm sorry, it's target.checked. All right, I did that all very quickly because it's essentially the same thing. Now this time, if I refresh, and the check, come on. You know, .NET Watch is not watching the way it should. You know what? Let's not even .NET Watch. Let's just run. All right, so there we go. We have the checkboxes syncing across each other. If I type Kevin, it syncs across the two boxes, and everything works, and everything was good to go. I'll let you in a little secret. Like 90% of the engagements I do is that to a little bit more complicated extent. We do a little bit more focused who we send the messages to, but at the end, everything boils down to send async to a particular client, the different set of information. Let's talk about clients for a minute, because this is an entire section in SignalR Mastery, but I think it's really important to show you the kind of the power of what SignalR can do. There's a big collection by being a part of the hub called clients, and you can send literally to any connected client to your server as you want to. But sometimes you don't want to manage each of these individual connections. What you'd rather do is tell SignalR, filter these clients in some way, shape, or form for me. So let's talk about a couple of ways that you can filter the messages that you can send. Let's assume you have a server, you have a variety of clients, A, B, C, D, E, F, so on, and you want to send a message to all the connected clients. Well, you do that using a pattern like we just kind of saw a moment ago. The clients.all, that means all connected clients, execute some method locally. They all get that message. Perfect. Sometimes you want to just make a return call to whoever made an initial call. So we call it the caller. Let's assume I'm client A and I type in Kevin and send that up to the server. And I want a message to go back only to client A, the person that had made that original request. Well, I can say clients.caller, and that filters all the clients down to just me, the person that made the original request. I get that message back. No one else will get that message. Perfect. Well, what if I want the inverse of that? I want everyone other than me. And that's what we were just doing. And clients.other. So if I, A, make a request to the server, everyone that's not me will get a response. And this is really useful if I'm managing my state locally. So I make a change. I send a message to the server. I already know what the change is, so I don't need a message coming back. But everyone else gets a notification that something had occurred. Awesome. You can filter this down a lot more granularly. Basically, because every connection has its own unique connection ID, you could say, well, let's get all the clients except C and E. Those folks don't get the message. And SignalR will filter that for you. And this is based off the connection IDs for the individual connections. I'm showing you this, but if you watch SignalR Mastery, I literally will tell you to never do it this way. This is a bad way of doing it. You could call a particular client. So if you know their connection ID, you could say, all right, we'll send this message specifically to Kevin's third Chrome window. Well, you can do that because we know the connection ID. If I have multiple tabs, they all have individual connection IDs, and that's a good thing. But in this case, you can send directly to a particular tab that you want to receive that message. Again, never do it this way, but you could. You can pick as many clients as you want. So if you know, all right, Kevin's tabs, third and fourth tabs, let's send a message to those, D and F. All right, they all get the message. If you're using identity or any identity layer that implements iPrinciple, you can reference particular users. So if I'm logged in as Kevin, but I have multiple tabs open, I could just tell SignalR, well, send this message to Kevin or Kevin's principal name. And SignalR will automatically know, all right, these are the connections associated with Kevin. And it'll send that message appropriately. I don't have a problem with this. You can also stack that up. You can say, well, send it to Kevin and Sally if you have an enumerable, and they all get the message. I've had mixed results using iPrinciple. I don't rely on it. I don't recommend using it. I've had issues with it in load balance scenarios. It's not my go-to way of fixing these particular problems. So I know what you're asking is, Kevin, well, if you don't recommend using connection IDs to send messages or track people, and you don't particularly like using the principal name to send messages to different people, how would you manage all these things in a way that works consistently all the time? Well, let's move on to the last little bit of conversation for this talk, and that's grouping. And we'll do that with a demo. All right, so let's go back to our app and let's go ahead and let's talk about another aspect of the app that I haven't really talked about, is that I have a background service, a hosted service running that creates new users, or it's a new user notification service. And it's sitting here, and every, what I have, 10 seconds, give or take, it is going out and getting information about a new user, and I want to notify people that are currently connected to the site when these new users arrive. Well, I need to do that using SignalR. Well, actually, a couple of questions come up here. How do you access a SignalR context, or how do I access that big group of clients outside of the hub? Because I told you clients only exist because I'm inside the hub. I'm implementing the hub. So how do I get access to all that client information? Well, great thing is we're using dependency injection with ASP.NET Core, so we can just inject all that functionality. So in my new user worker, oh my gosh, thank you, GitHub. It automatically filled in the blanks, but I can inject an iHub context for my sync hub, which is essentially just an instance of this class that gives me a reference to all the connected clients. Let's see. Oh yeah, I screwed up all that stuff. All right. Let's go ahead and save it up there. so we can use it later. What are you complaining about? Did you mean time remain to the same? Oh, yeah. I understand. Yep. There we go. So let's save it away for a rainy day. We'll go into our execute async, which is doing all this work. So every couple minutes, every couple of seconds, it's getting information about a new user. And we need to notify anyone that's currently out there listening that a new user's come in. So I have to do SignalR. Well, let's take a step back. We know we have these two buttons, start notifications and end notifications. And I want to use these as the triggers to whether or not I get these messages, because maybe I don't want these messages all the time. So let's wire up let's create two client methods, start notify and end notify. I'm just going to paste these in place. So when I click the button, we'll call a method start notify on the server. And I'm going to tell SignalR to take my current connection and add me to a group called notify me. Likewise, if I press the end notify button, remove me from that group so I don't get the messages ever again. Over on the client, I already have the buttons for start and end. We'll go ahead and make the calls to each of these. So send a message, start notify. Notice I'm using send instead of invoke. Actually, there's a difference between them. When you use send, it sends a message. You don't, crap. You know, I wrote the course. I'm trying to remember the difference. The difference in send is that you get a response promise. So you know if the request actually went through. So I'm going to say they're interchangeable, but they're technically not interchangeable. It depends on what you want your end result to be. All right, so we say start notify for the start, and we'll do end notify for the end. And all right, so when I click on the start button, it sends the message to the sync hub to add me to the group. It's going to return. Toastify is going to pop up and say, hey, we're listening for notifications. Likewise, for end notify, we send the message to the server, takes us out of the group, and shows us the toast all over again. All right. Well, that's good. Now, what happens when we actually get the notification? But add another handler in here called new user. Well, when this happens, we're going to put a toast up on the screen that has a little bit of information about the new user, specifically their name, and there's also a little gravatar for each individual user. Well, we need to trigger that part, the new user part, and that's done inside of the new user worker. When we're ready to send a message to our clients, I can say hub context, give me not all the clients that I'm asking for, but specifically give me people in the notify me group. And from that subset, I want to send a message asynchronously to say call the new user method, and we'll pass in not R, but it's technically r.results, and we'll get the first item. I have squigglies. Should await that method. All right, sidebar. If you don't await it, you're going to run into some problems. Specifically, what's going to happen is if you're in a case where you're not awaiting on your sends, they might not actually go through. I've had a client once where that was their specific use case, was it would run fine on their machines, but once they were up in production, anytime send async was trying to send a message down to a client or a set of clients, sometimes it wouldn't go through. Turns out they weren't awaiting on their sends, and threads were terminating before the message could actually get down to the individual client. So always make sure you await tasks when they pop up. So if you don't get the squigglies, you should get the squigglies in current versions of Visual Studio and even VS Code in a lot of cases. But if you're running in cases where your messages aren't going down to the clients, you might have forgotten an await. All right, so we'll wait on our hub context. Yay, yay, yay. Let's go restart our server. Abnormally too much time to restart. All right, so okay, let's go ahead and put these side by side. I want to refresh. Refresh, we're connected. Refresh, we're connected. I'm going to press start notifications. And if we wait a moment, say, welcome, Liv. And a little picture of Liv. And then we wait another 10 seconds. We'll get welcome, Victor. Victor's got the thumbs up. Cool. So they're popping up over here on the right, but you notice there's nothing over here on the left. Let's do the same thing. Let's hit start notifications. And say Aiden just came through a moment ago. Oh, we'll wait. We'll wait. Ludwig. So Ludwig pops up on both sides because they're both listening for those messages. Both these clients are inside of the group. We'll wait for one more. So Burn Dieter. Cool. All right. I want to end notifications on the left side. We'll wait for one more cycle. Moment now. Welcome. I don't know how to pronounce that name, but welcome to the users. But you can see I can add or remove myself from groups as necessary. Commonly, what we do in our apps, when someone connects for the first time, you can actually, protected override? Oh, I'm not going to get my IntelliSense here. It's unconnected async. I'm pretty sure that's it. Public. All right. So you override the unconnected. There's also an on-disconnected event. What we like to do is when a user connects, we create a very specific user group name. So we'll say user dash and fill in the blank, say the username. We add a person to their own group. So if I connected and I'm Kevin, well, I have a Kevin group. So then anytime I need to send a message to Kevin, I don't want to track individual connection IDs. I send the message to just the Kevin group. So that ensures that every tab I have open on any or multiple devices, they all get the message. And you might be thinking, Kevin, why would you do that if you have connection IDs? Can't you just use the connection IDs? Connection IDs don't work very well in a scaled environment. So if I'm running this app on 3 different servers behind some sort of load balancer or reverse proxy, you're going to run into issues because these servers can't communicate with each other. There's a process for setting up communication between those servers. It's called a backplane. You also have the Azure SignalR service that does a really good job of helping there. But they don't work well with connection IDs. I would say they don't work at all with connection IDs, but there are some times when they do work accidentally. But always found it's more consistent to use groups than managing connection IDs by themselves. So that's why I said through the clients, don't use connection IDs. I have at least like 2 blog posts that talk about why you shouldn't use connection IDs. And so I can reference those in the chat if you really want to debate me on it. But I love groups. We use groups all over the place. Now, let me show you a real example of an app that I've written. I still help maintain it, but we use groups extensively. So let me, before I do that, all right, groups. I don't really need to go into this logic for you, I don't think. But basically, when you send to a group, you can still do some filtering on the group itself. So if you have multiple clients in different groups, so let's say there's a yellow group or an orange group, you could send to just all the folks in orange, and they all get the message. Cool. You can filter that down and say, all right, well, send to everyone in orange except connection ID E, and it'll do that. I've never done that. I don't know anyone that does that, but you could do that if you wanted to. You can send to multiple groups. So I have yellow and orange, but it could be sales, marketing. Send this to the Kevin group or the Scott group or the Lee group. They could all get the same message. Others in group, basically. So if I'm the caller and let's say I'm A and I'm in the yellow group, send to everyone else in yellow except me. That's what others in group does. That's super. That's kind of useful, right? Now let me show you the real world application. I'm going to shut this down because I am hitting their API. If you've never used the random user.me API, it is super fun. Just go to randomuser.me and check it out. They have very high tolerances for rate limiting, so you can hit this as many times as you want to in a demo, and it doesn't phase them. So good demo. All right, let's go look at a real world example. So this is an application I helped work on years and years and years ago. It's called Livecat. This is a group based out of Southern Ohio. And what it does is it aggregates 911 data. So because most folks watching this are probably based in the US, you know, the US covers a large amount of land. And there's cases where, you know, so if you're up in Northern Virginia, you don't necessarily have this problem. Your local city has a 911 dispatcher. You have fire and paramedic services just down the street. It's probably not a big deal for you to have emergency services. But when you start venturing out west, in the counties are a little bit more broad. You might have two counties next to each other that both provide volunteer emergency services, but the closest emergency service to you might not be in your county. It might be one county over. So what these folks did is they actually aggregate the 911 data from all these different counties, and we build these configurations, these dashboards for different counties or sets of counties. So if I'm in a firehouse in, let's say, Newark Township, and I see an alert come in, well, I see an alert come in from one county over, I can look at this and go, oh, that's something that we can respond to faster than the township over can. So we might be more likely to go answer that request than the actual township. When I first came onto this application years and years ago, it was kind of the example of it was running under a desk. It was IIS running ASP.NET 4 point something, and it had SQL Server on the same machine. All the logic for colors and stuff and whatnot, that was actually all rendered in SQL Server. There was this huge stored procedure that did all that computation, and then it would render the web page, ASP.NET Web Forms, and this was inside of an update panel. So folks who have not had the pleasure of working with an update panel in ASP.NET, long time ago, the way it worked is that the update panel would exist client side and would update itself on an interval, which basically meant let's send the request to the server, re-render the entire page, send the entire payload back down to the client, and the client would only update the update panel. Okay. This app had the update panel at 1 second. So every 1 second, for every person, every tab, every window was going and hitting this poor server that had SQL Server on the same box, running this massive stored procedure to figure out what it should be looking at. So client came to me and said, we have a problem. We're just at 100% CPU all of the time, and we don't know how to easily fix this. So we went through and we rewrote the entire application, kind of what you see now. .NET Core, using SignalR for deploying deltas. So we send the initial page state down to each individual client, but then the connection just stays open until an event occurs that this page needs to know about. So what ended up happening was we went live, moved all the users over to this new page, and the CPU was literally like 0%. It wasn't doing anything. And as a developer, I got really scared because I thought nothing was working at all. Turns out it was working fine. It just had no work to do because there were no changes coming into the application. All right, so we did all this work and it was amazing. I was super happy with the progress that we had made. And fast forward a couple months, I heard about this story. It was a firehouse in it was Southern Ohio somewhere. I don't remember where, but it was a firehouse, and they have Livecat up on big screens, so everyone that's currently in the firehouse can see it. And what happens is when there's an emergency that the folks need to be aware of, and thankfully it hasn't happened while we've been sitting here on the page, the screen actually flashes red. So it's bright. If you saw it out of the corner of your eye, you would not miss it. Pause there for a second, because if you're watching the page, it's updating in real time. So we they said they saw it. Oh, here it goes. See, it's flashing yellow. So something's happening. There's a sick person. That's about all we know. And a truck has been dispatched, and hopefully here in a moment they'll say en route to the destination. So maybe they'll get there in time while we're here on the live stream. So the screen flashed and the firefighters went, all right, that's something we need to respond to. They start putting their gear on. They get in the truck and the doors are opening and the truck is pulling out of the firehouse. And at that moment, the dispatcher comes over the radio saying, there's a medical emergency. Please respond as soon as possible. Like minutes have passed from Livecat showing the initial incident and the dispatcher coming over the speaker. And anyone out there who's had a loved one or them themselves have dealt with a medical emergency that's a heart attack or it's a stroke, you know that every second matters. The sooner that we can get someone to the emergency services that they need, the more likely they are to survive. And we have built a system using just WebSockets that was able to accomplish this. So this is why I say, .NET saves lives, SignalR saves lives. And I mean that kind of in jest, but this is a real example of an incident where this really happened. Underneath the scenes, all this is groups. It's groups making these little one-off calls, saying, all right, send this message, send that message. And not very much is happening on the actual server itself. So the changes come in, we process them, we send out the deltas to everyone that needs to know about it. But I love talking about this app because this is one of the first big SignalR apps I ever did. But I think this is the most meaningful. This is not what, if you mess up the email count in a notification, no one gets hurt by that. But you do it right in this app, people's lives could be better for it. So, with all that said, let's go to my fancy little. Thank you so much for coming tonight. I'll stick around and answer all your questions. And now with my sob story about how I'm saving lives with SignalR, you can save lives too by going to SignalRmastery.com and grabbing the best-selling Udemy course on SignalR. And I say that as there are like 6 courses on SignalR, and the other ones are really bad, like horribly bad. Oh my gosh, they're so bad. You should buy my course because it is literally the best course on SignalR on Udemy. So I highly recommend that you go pick it up. And it's on sale. It's not $12.99. It's like $14.99. But go to SignalRmastery.com because then I actually get credit for it. And I would greatly appreciate that. But I'm happy to stick around, answer any questions you all have while I'm here. So thank you.
if you have any
Yay.
questions, thank you. If you have any questions, feel free to either put it in the chat or you can just unmute your mic and go ahead and ask. We have mics are enabled, so if you have a question, just feel free to unmute and ask the question. Anybody?
I'm going to drop GitHub links in the chat for anyone that's interested, including SignalR Mastery. Yeah, you should totally go buy my course. And I'm watching y'all.
What course was that again, Kevin?
The SignalR.
SignalR. Arg. Yes. Niles says it's time to expense a course. That's a great idea. Yes, it's so inexpensive. You just expense it as lunch. Just go in and say you bought a cheeseburger and watch.
You know, if you're expensing it, you might as well get like 5. I mean, 5 copies of it. That way.
Yeah. I mean, how many copies? I mean, I think we need multiple copies of it. Anybody have a question for Kevin before we let you all go?
I had a question from earlier. I was curious how common is it to have multiple hubs? It seems like the kind of thing you'd only ever need one of.
Remember how I said I accidentally DDoSed myself? It's because I had multiple hubs. And so the longer story there is, so SignalR came out in 2013. It was originally for .NET, ASP.NET full framework, and in that implementation of SignalR, if you would have one WebSocket to rule them all. So if you had multiple hubs, and we approached it like controllers. You have multiple controllers for multiple use cases. So we had built multiple hubs for different use cases, and you only ever had one WebSocket. And SignalR would filter the request going through that WebSocket to the appropriate hubs. When they rewrote it for .NET Core, they changed that so every hub had its own WebSocket. And we had moved our application to .NET Core. We are doing the transition to SignalR on .NET Core and deployed it. And I knew it was a WebSocket per hub. We had 5 hubs that we're establishing. And our users usually have 6 to 10 tabs open to our app at any one time. So for one user, if they had, say, 10 tabs, each of those tabs had 5 WebSocket connections. One user could easily use 50 connections all on their own. Now multiply that by 900 users, all concurrently. We had 3 servers running, and we killed like 2 of them. We exhausted the sockets. And this is before the tools. We were running in Azure App Services, and the tools were not as good back then to tell you what the problem was. And we just have these periodic like moments of slowdown. It's like, well, what the F is happening? And come to find out, I'm just going through app services. It's like, oh, socket exhaustion. What do you mean socket exhaustion? And then I'm sitting there doing some rough math, and I'm like, oh no, I screwed up. Like I screwed up badly. Like I did not account for like all these users having 5 connections per tab and then having multiple tabs open. So yeah, I don't know if you've all had to do like seat of your pants rewrites of entire pieces of your code base. But I spent a couple hours taking 5 hubs down to, I got it down to 3, like was the best I could do. And actually it was enough to fix a lot of cases. We bumped up the app service plan so we would get more RAM per individual machine. So your connection pool is based a lot off the amount of RAM you have available to IIS or IIS. And so we were able to get it steady until I could do more further refactoring. But now we advocate one hub that does all the things for your connections. if you're going to have multiple hubs, the only cases I would do that is for very specific users. So say you have an administrative hub, or a very specific type of user has their own hub connection, because you can control authentication to the hubs based off of like roles. So only administrators should be able to connect to this hub. You can control that. But yeah, learn that the hard way, and I talk about it in the course. So it was a very much a lesson learned.
Does anyone else have any? I've got one more question. Does anyone else have any questions?
Bring them on.
All right. My last question is, every time I use SignalR, I find myself, once you sort of get it implemented in a site, at some point you start thinking, or at least I start thinking, well, should I do this with an HTTP request, or should I do this through SignalR? And then you start thinking, wait a minute, why am I doing HTTP at all? Because SignalR is so much more flexible. So do you ever wonder that? Do you ever just think, you know what, I'm just going to throw away all my HTTP requests and do everything with SignalR?
Yeah. I'm not necessarily a huge fan. So one of the things you have to remember with SignalR is, so the nature of the WebSocket and the nature of how it communicates over the WebSocket, your throughput on that WebSocket is not necessarily guaranteed to be in a specific order. So deltas are a good example. The Livecat example I just showed. There's a potential case where I could be firing messages down that WebSocket and they're not received in the order that I would perceive them to be received in. So, or processed in the order that I would expect them to be received. So one of the things that we do on our end is we timestamp all of our messages as they're sent. So if a message comes in that's older than a message we have already processed, we throw it away. There's also cases to be made for like data validation. If you're sending a request up through a WebSocket or through SignalR, and you need to do some validation on that, now you're basically returning custom error messages if things are not correct. Now you have to build custom handling around the events if errors occur. The one thing that HTTP has going for it is that they've kind of solved the request response cycle of data. If I make a request and it's invalid, I'm going to get a 400. If I make a request and I'm not authorized to do anything, I'm going to get a 403 or a 401. If I do something and I break the entire server, I'm going to get a 500. Like that's just understood universally across all apps. So what I like to do is I like to initially do anything that's critical. I will probably still do an HTTP call, especially if I need to know whether or not that request made it to the server to begin with. You could potentially have cases where you send something down a WebSocket and you don't know if it ever makes it there. There are things in place to let you do that, but there's no acknowledgement cycle. One of the most common questions we get in the SignalR Mastery course is, how do you guarantee all the messages that you send get received by the client? And the answer is you don't. That's just not something that happens. Because I've had numerous people go, oh, well, we'll just design this whole message acknowledgement system. Like, well, yeah, you're going to be working on that for decades because it just doesn't work like that. And because do you acknowledge the acknowledgement? It's like, all right, well, I send a message, we'll acknowledge it. So we send the acknowledgement back. But do I acknowledge that the acknowledgement was acknowledged?
Right, you're re-implementing HTTP. Yeah.
So at that point, you're just going to drive yourself crazy. It's the same thing with connection IDs. Like, don't track connection IDs because they're not reliable. Don't try to do message acknowledgement. It's not reliable. It's not going to work the way you expect it to. What we do, and I've had numerous clients contact me and we build up systems, and it all starts with, you have this end-to-end connection. if you're using a WebSocket and it's connected, there's a 99.999% chance your message is going to make it no problem. Like you can just trust the platform there. However, if you become disconnected for any period of time, even if it's 100 milliseconds, you could have not received a dozen messages. So what do you do in those cases? And especially if it's a mission critical app. My go-to response is you assume all your data is bad. You throw it away and you start from, you refresh the page, or refresh the data set. We build in methods that just say, I don't trust any of my data. Give me a fresh state. And it works really well. And that's anytime the data becomes disconnected. You also run into potential issues if you're not on WebSocket. So if you're on server send events or if you're on long polling, your data is probably not going to come back in the order that you expected to come back in. It could be batched. It could be, now is before like 3 seconds ago. It could potentially be out of order data. So yeah, that's why I would use HTTP over SignalR in a lot of cases.
Cool. Good stuff. All right. Well, I think I'm going to stop the recording. If there's any other questions. Oh, wait, here we go. What's your take on Blazor SignalR from John Bechtel.
Let me know when you've stopped recording.
Okay, sure. I can. You want me to stop recording? Okay.